Okay, so session is recording. Okay, so so today we'll cover the HANA system replication and then the DMO. So we'll see the theory part today for the HANA system replication, and maybe the next the session I will go with the practical. So let's start with the HANA system replication. We already last time we already covered what is the HANA system replication. Basically, it is used for HA or DR configurations. If you want to build HA systems or DR, then for HANA we use the HANA system replication. HANA system replication is supported for the scale up system basically. So if you see here, the primary and the secondary board should be identical. Okay, so same SID, the same instance number, okay, same number of active services should be there. And in the replication, the data in the logs is transferred through the HANA database kernel. So when we install the HANA database, the kernel is installed automatically. Okay, HANA kernel database, and it shift the transfer the data or the logs to the secondary. Okay, so this is just high level. We'll see in detail. So in HANA system replication, to set up the HANA system replication, we provide the replication mode and the operation mode. So what is that replication mode and the operation mode? So replication mode is nothing but providing the acknowledgements, how the data is replicated. Okay, how the data will be replicated, whether it is synchronous, asynchronous, something kind of. So the replication mode, we have the four types of replication mode: synchronous, synchronous full sync, then synchronous in memory, then asynchronous. The synchronous and synchronous full sync, and third one is sync in memory, that is synchronous in memory. These three are used for HA configuration within the data center. If you want to configure the HA within the data center, then we use this first three the method for three replication mode. Asynchronous is basically used to build the DR systems between two data centers. Okay, so you have two data centers, primary in one and the secondary in another data center. Then you use the asynchronous mode. So during the configuration of the HSR, we provide the replication mode. So what is the synchronous? If we select a synchronous mode as a replication mode in HSR, HSR means HANA system replication. So so sync so mode is sync. So when we configure, then we have to type sync. Okay, so if we see that bracket sync is there. So in this mode, if you set the replication mode as a sync, then secondary system send the acknowledgement back to the primary as soon as the data are received and persisted to the disk. So meaning of this statement, the secondary request, once the HANA system replication is enabled, once HANA system replication is enabled, then secondary database request primary to send the logs, and then primary send the logs to secondary. So primary continues send the logs to the secondary, and secondary receive, and then secondary send the acknowledgement that I have received the data, and also I apply the data in secondary database. Okay, so that is the meaning of synchronous mode. So when the connection, so the connectivity should be between primary and the secondary should be stable. If you are using the synchronous, sync full, and then sync in mem. So what happen if the connection is lost between primary and the secondary? In that case, what will happen? So in that case, the connection if the connection to the secondary is lost, the primary systems continue the transaction processing and write the changes only to a local disk. So, so the primary continues send the logs and the data to the secondary. If secondary is not available due to the, you know, the power failure at the secondary systems or network problem between primary and the secondary, and the communication is stopped. So in that case, primary continue the transaction. So whatever transaction the users will do, it will continue. There won't be any problem. Okay, but whatever the changes is happening in the primary database, okay, that will store on primary local disk. Local disk means we have the HANA shared, sorry, we have the HANA log SID. So in that it will store all the the logs. Okay, so log segment is there. In the log segment, it will store all the logs. Then once the secondary system is available, then it starts sending the all the backlog. Okay, so primary will send all the backlog once the secondary system is available. So in the sync mode, you won't see any issues. Okay, okay, but if you are going with the synchronous, okay, full sync, okay, so there is a parameter to set the full syncs. Okay, so you have to say you have to use the replication mode sync, and then in the global dot INA uh, configuration dot INA, we have to there is a some parameter to enable the full sync. Okay, so if you enable the full sync, okay, then what happen in this one? Okay, so it is same like a synchronous sync. Okay, but if you enable the full sync in the INA files, then if the in this case if the secondary system is not available, if the secondary system is not available, then the primary will stop taking the transactions. So the user will not able to perform any commit transactions. So in the primary database, if secondary is not available, then primary system will block. Okay, and transaction processing will stop. No transaction will be committed at the primary database. Okay, and user will face some downtime. So in this full sync, the systems granting a zero data loss, but it has some disadvantages. If the connection is broken between primary and the secondary, then user will face a downtime. User will not able to execute any committed transactions. They can read the data, but they cannot write anything at the primary database. So system will not allow you to write anything to primary database. Any questions between these two?
No. Yes, but even in synchronous, there is no data loss, right? Because once the secondary is up, it is writing all the logs back into secondary.
Yes, yeah, correct. There's no data loss, but uh, in the sync mode, if you see, yeah, in this case also data loss is not there, but SAP says that near zero data loss. Sorry. So ACP says that if you use the synchronous, then it guarantee a near zero data loss. How much data will loss? Don't know. So we consider as a 10 minutes data loss for the synchronous. But in the full sync, you ACP says that it guarantee a 100% zero data loss, zero data loss. But in sync, it says that near zero data loss. So near zero data loss means it can be anything, either 1 minute, 2 minutes, something kind of. Because if the, uh, for example, uh, for example, you have the primary and the secondary database, okay, and then your the secondary database you're down. Secondary database is goes down. Something has happened. Okay, and then after that, suddenly your primary down, crash. In that case, your primary crash after 10 minutes, 5 minutes. Okay, then you will going to bring the your secondary, but secondary having some the sync is not from the primary, because the primary secondary goes down, and then after 10 minutes or 15 minutes the primary also crash. So in that case, if you see that some data losses is there. Okay, so SAP guarantee zero data loss in the full sync. So in the full sync, if your secondary is loss, okay, then primary will not take any transactions. Okay, so after that, if primary goes crash, then you have the secondary data is up to date. Got it?
Yeah, but in synchronous full sync, then we have to, we have downtime involved, right?
Not the downtime. The connection. So we know we don't use the full sync, because if you use the full sync, then you will be rely on the network. If your network is some having issues, some in seconds or in minutes having some breakdown, then definitely your primary will block writing anything. So there won't be any downtime, but the user will not able to perform any write transactions. So user will not able to save their transactions. User can log in, user can read the data, but users cannot perform the write operation. Okay, when I say write operation, any committed, they cannot commit anything. Commit means they cannot save anything in the SAP systems. They can log in the in SAP system. They can go to the change mode. They can type. They can do anything. And whenever they click save button, the save will not work in case of secondary is lost in the full sync. Yeah.
Yeah, thank you.
Any other questions? Fine. So third is the sync in MEM. Okay. So question is always come interview question. What is the difference between synchronous and the full sync? So you have to explain like this. The third is the synchronous in memories. So we also call sync mem. So sync mem is faster than a synchronous, because the synchronous is happening between memory. Okay, between primary and the secondary memory. So in this case, sync mem, the secondary systems send the acknowledgement back to the primary as soon as the data is received. So whenever the primary send the data to the secondary system send the acknowledge that I have received the data. Whether that data is applied to secondary, that confirmation in this mode, the secondary is not giving. Okay, that's the reason it is faster than the synchronous. Okay, so we basically use the sync mem. Okay, because it is faster. Okay, but here also the data is not the data will not be lost. So almost a zero data loss is there in this mode as well. Nothing will happen if if this is secondary system is lost. The primary will continue transactions and it will store the data, committed data to a local disk. And once the secondary system is available, then it send all the backlogs to the secondary database. Asynchronous mode, it is used for DR purpose. As per the design, asynchronous replication, the primary doesn't wait for the acknowledgement. Okay. Okay, so primary doesn't wait for the acknowledgement from the secondary. So primary keeps sending the data to the secondary. Whether secondary received or not, that is not that the primary will not bother about that. So primary will not wait for the any acknowledgement in case of asynchronous. Yeah. So the people ask what is the difference between synchronous then syncing, ma'am, then what is the difference between synchronous and asynchronous, when to use synchronous and when to use asynchronous. Okay, so multiple questions comes in this area as well from interview perspective. Fine, any questions here? No, okay, fine. Operation mode. Okay, so the operation mode in HANA system replication means what data is going to transfer to the secondary. So it depends upon the operation mode. So we have three types of operation mode in HANA database. The first, the classical one is the delta data shipping. When HANA systems is introduced, HSR introduced, that time SAP supported the only one operation mode was there, delta data shipping, till HANA 1.0 SP10. Till SP10 HANA 1.0 we use only the delta data shipping, only one delta data shipping was there. So in this method, so when we set the delta data shipping, then in this one, uh, your reader logs is continuously sent to the secondary. The primary send the reader logs to the secondary database, and then after 10 minutes, the primary also send the data, okay, delta data to the secondary. So in other words, whenever the transaction is committed in the HANA database at the primary side, and you use the delta data shipping, then the reader log is generated every committed transaction. That reader logs is transferred to the secondary. Okay, so second the reader log is continuously transferred to the secondary, and every 10 minutes the primary also send the delta data. Primary also send the delta data, that is the data, we can see that data to the secondary. So every 10 minutes the data is also sent to the secondary. Okay, so in this case, if you see that if you use the operation mode delta data shipping, then the 10 minutes of the data is loss is there, okay, by default. So every 10 minutes it send the data to the secondary. So if you see that if your the primary or secondary is crashed, for example, then the if the data delta data is not received by the secondary, then there is a 10 minutes of the data loss. So delta data shipping guarantee 10 minutes of data loss. Okay, so that is the classical one. Okay, then after the HANA 1.0 SP11, HANA SAP introduced the log replay. So the log replay mode, if you use the log replay mode in this, it is faster than a delta data shipping. If you use this mode as a operation mode, then in this case only the reader log is shipped to the secondary. Okay, no delta data transfer to the secondary. So it is very faster than the recovery, that is the recovery time opportunities are also the faster in this one, in this case, and zero data loss is there. Okay, so yeah, so I'll explain this in the through the diagrams. So this log replay is introduced in HANA 1.0 SP11. Okay, the third one is the log replay underscore read access. Okay, so I have not mentioned here. Okay, so if you use the log replay underscore read access, okay, in that case, yeah, first in this two, if you see the delta data shipping and the log replay, in this case you won't able to log into the secondary. Okay, so secondary will be inactive. The primary will be active. The everyone is connected to the primary, and the primary continues send the data and the logs depends upon your operation mode to the secondary. And you cannot log into the secondary through the HANA Studio. Okay, but if we set the log replay underscore read access, then the secondary will take the read command. So you can log into the secondary database from the HANA Studio. Okay, but in the delta data shipping and the log replay, you cannot log into the secondary database. Okay, so if you see here, log replay underscore read access, in that one the primary will continue receiving the read and write, but the secondary will only accept the read uh, access. So you can only read the data from the secondary database. So that is the only difference. Rest are same. Any questions here till now?
The read access is not written in this slide.
Yeah, it is not written yet. Yeah,
Okay.
so yes, it is same as the log replay, but only the difference is that it has the ability to allow you to log into the secondary database through the HANA Studio.
Okay. Yeah.
But you can only perform the read operation. You cannot write anything in that database. Okay. Got it?
Yes. Yeah.
So what data is transferred to the secondary? Hey, Rakesh, any questions from your side?
No, it's fine, sir.
So basically, what data is transferred to the secondary? So the thing is that we have three types of data. We have three types of data is transferred to the secondary. The first is the full data shipping we called. What is that full data shipping? So when we configure the HANA system replication, once the HSR is enabled, okay, before that enabling the HSR configuration of the HANA system replication, we take a backup of the primary database. Okay, we take a backup of the primary database. Once the backup is completed, then we enable the HSR. Okay, so once the HSR is enabled, then the whatever the backups we have at the primary systems, that is transferred to the secondary. That is we call a full data shipping. So initially the full data will shipped or transfer to the secondary. Okay, then after that the delta data shipping and the log redo logs or data shipping will transfer according to the operation mode. So full data shipping, the full set of the data is created as HANA in place snapshot of the disk. Okay, of the primary is initiated sent when system replication is set up. So yeah, so whatever I said, it is like that. So before setting up the or enabling the HANA system replications, we have to take the backup of the primary database. Once HSR is enabled, then that backup is from the primary. That backup is sent to the secondary, and then after that, based on your operation mode, the data will transfer. So in the delta data shipping, the it is only used when if you use the delta data shipping operation mode. So incremental of data will transfer to the secondary. Okay, so 10 minutes, every 10 minutes, whatever the data is changed, okay, that data will be transferred to the secondary database. Log replay means the every committed transaction at the primary, the redo log is generated and that redo log is shipped to the secondary. Okay, so that is we also call a raw log buffer. Okay, so in the diagram, if you see, okay, for the data shipping, so here we have the primary database, here we have the secondary database. Okay, so we have you have to take the backups for your primary database, then configure the system replication. Okay, once you configure the system replication, this is your full database backups. Okay, so that full database backup is transferred to the secondary. Okay, and then after that, this is the redo logs. So this redo log is transferred to the secondary. So this redo log is generated for each and every committed transactions, and then after every 10 minutes, delta data. So after this full database backups, whatever the whatever the data is changed, that is the delta. So that is transfer to the secondary database. like this. If you say that every 10 minutes, delta data, delta data, delta data. If you consider, if you see this one, and if you see your backup and recovery, so you can see that this is the full database backups. Okay, then this is the logs, and then we can say that this is the incremental backups. Okay, like this. This is this use the yes.
Sir, your voice is not audible.
Yeah, 2 minutes. Yeah, just 2 minutes.
Okay.
Okay, sorry. Actually, another some things is going on. So migration is going on. So I'm just monitoring the systems as well. Yeah. So here, if you see the backup and recovery, if you consider with the backup and recovery, so in the backup and recovery, this HANA system replication uses the backup and recovery methods. So full data is transferred. Then after that, whatever the data, whatever the logs is generated at the primary, that is sent to the secondary, and then secondary apply those the logs to the secondary database. So it is using the backup and recovery and the mechanism for the HA configuration. If you see the log replay mode, so here we take the backups. Okay, this is the backup. Once the HANA system replication is configured, then the full data is transferred to the secondary, and then these all are the reader logs. Okay, these all are the committed transactions. Okay, so it is shipped to secondary. So here the no delta data is transfer. Okay, only the reader logs. That's the reason it is faster, and its guarantee is near zero data loss. Okay, so data losses is basically depends upon the operation mode, what operation mode you are using. So yeah, any questions here? I'm audible, right?
Yes.
Yes.
No question.
Okay. So what are the prerequisites to set up the HSR? So the primary and the secondary systems should both installed and configured. All the configuration steps have to be executed on the master name servers, that is the primary database. Okay. SAP HANA software version of the secondary has to be equal to the primary. If you have the higher version on the secondary, no issue. Okay, but it should be equal or greater than the primary. So make sure that secondary and the primary both having the same both having the same version, same HANA database version. Then the secondary system must have the same SID. So the SIDs and uh, instance number, then the password, everything you have to keep the same. Okay, so keep same the primary and the secondary SID, instance number, password, everything. Primary replicates all the relevant license information to the secondary. So coming to the license part. So how many licenses we require? We have the primary database, we have the secondary database. So how many licenses is required? So here we only require one license for the primary database. Okay, that license is automatically replicated to the secondary. Okay, if it is the HSR. Okay, so yeah, so only one license is required. We apply the license in primary, and HSR in the HSR, that license is transferred to the secondary. System replication between two systems on the same host is not supported. Okay, you won't able to install the two SIDs on the same database. Okay. Changes to the INI files configuration parameters made on one system should be automatically duplicated on the other systems. So from the HANA 1.0 SPS 12, the whatever the configuration parameter you change at the primary, that automatically reflected or change to the secondary. So that is also getting changed. So earlier we do the manual configuration whenever we do the INA configuration at the primary, then the same we have to do the at the secondary side as well. Okay, manually. Okay, but now that is avoided. So in HANA 1.0 SPS 12, if you have HANA 1.0 SPS 12 onwards higher, then it automatically replicate the INA file as well. So initial data backups or snapshot must be performed on the primary before the system replication activated. Before the system replication, you have to take a backup of the primary database. Use separate network for the system replication. So the system replication between the primary and the secondary, we have to use the separate network. We have to ask network team to configure the separate network for the system replication. All nodes must be in the same network segment. So your primary and the secondary board should be in the same network segment. Fine. So if you see, I forgot to forget one point. So delta data shipping is introduced. Um, yeah, it is supported in the HANA 1.0 and 2.0 as well. But from the SPS 11, we have a log replay. Okay, and then log replay underscore read only. Okay, read access. It is there in HANA 2.0. Okay, not in HANA 1.0. Okay, so that is the difference. Yeah. So log replay is introduced in HANA 1.0 SPS 11. It is there in the HANA 2.0 as well, but the log replay underscore read access, it is introduced in HANA 2.0 only. Okay, so it is not there in HANA 1.0. Any questions in the prerequisites? No. Right.
Sir, only one license is required for DR cases also.
Yes. Yes. Yeah. Fine. So takeover is manual process. So if you see that you have the primary and the secondary, you have enabled the replication. Now your replication is going good. Okay. What happens if the primary is down? Okay, if the primary is down, then we have to go and then bring the secondary as a new primary. So this takeover process is the manual process in the HANA database. Okay, so the command is there sr underscore takeover. If you execute that in the secondary database, log into the secondary database SIDNM and then execute sr underscore takeover. Then your secondary will become a primary. What happened? Yeah, so this takeover is manual, and it required 10 minutes almost to perform the takeover. And then if you have application connected to the HANA database, then you have to repoint your application to the secondary. Okay, so in the SAP profiles, default profiles, if you see that there is a database host name, so that database host name you have to change if you want to perform the takeover. So you have to give your secondary the host name in the default. Okay. So during the takeover, yeah, so SAP will stop. Okay. So because the primary will not be available and you are doing the takeover. Once the takeover is done, the secondary become the primary, then you have to change your profiles. Okay. Default the profiles, you have to change the host name. Also, your application So if you have the multiple application, then on each and every application, you have to log into the OS, and then you have to log in with the SID ADM, and then you just update the HDB user stores. Okay, so the primary host name you have to replace with the secondary host name. So HDB user store is there at the application side. You have to update that one. So whenever you perform the takeover from the primary to the secondary, once the takeover is done, then you have to change your profiles, default profiles, the host name of the secondary, and also in the HDB user store, you have to change the host name from primary to secondary. Okay, this is the manual the process. So it takes almost 30 minutes to perform the takeover, whether it is HA or the DR. Okay, so this is the manual process. But this manual we can automate. Okay, how we can automate? We can automate through the pacemaker. Okay, so through the pacemaker. So the pacemaker is the cluster software. It is supported on the SUSE and the Red Hat, the Linux, which do the auto failover in a seconds. Okay, in a milliseconds even. So user will not face any downtime. So the with using the pacemaker, we automate the takeover. Okay, which improve the service level agreement as well. Okay. So if you see this pacemaker configuration, this pacemaker is configured by the OS team. So we don't configure the pacemakers. They configure and maintain the pacemaker. So we have to just install the primary and the secondary. We have to enable the replications. Once our replication is enabled, all the data is sync. Okay, the secondary and the primary are in sync. And then after that, we ask them to configure the pacemaker. Okay, if the customer has the license for the OS with the pacemaker, then yeah. So pacemaker is by default it is there, so no license is required. Okay, so so they configure the pacemaker and they need some input from us like SID, then host name, then instance number. So those we have to provide to the host team and they configure. The pacemaker is work on the virtual IP address and the virtual host name. So any cluster softwares work on the virtual host name and the virtual IP address. So this virtual host name or virtual IP address, will be floating. Okay, will be floating IP address we call it. So it will float between primary and the secondary. So pacemaker, if pacemaker continuously monitor your primary database, okay, it's in the broadcast message, and then the primary send the acknowledgement to the pacemaker. Okay, so initially virtual IP will be pointed to the primary because primary is your primary database always it is active because the primary sending the the message to a pacemaker that I'm alive, I'm alive, I'm alive. Once the if some issue is happen at the primary and pacemaker notice that I'm not getting a response from the primary, then pacemaker consider that primary is not available. Then it suddenly bring the secondary as a primary, and then virtual IP will be will float to the secondary, that is the new primary. Okay, and all the your application is connected to the your virtual IP address. So you don't need to change anything your at application side. You don't need to change anything in default profiles. You don't need to change anything in HDB user stores. Okay, if you are using the pacemakers, because pacemaker does the auto failover. So all your application from HANA Studio, you will be connecting to the virtual IP address or virtual hosting. Okay, so this virtual IP or the virtual host name only automatically point to your primary database. So whatever the primary database is there, whatever the database is active as a primary, there it will point. So that is the beauty of the pacemakers. Okay, clear this one? Any questions?
What is this HTTP user store? I mean, where do we configure this?
So yeah, if you see that we have two mechanisms. So you know that sec store, right? Sec store means SSFS. If you have work on the Oracle, for example, so Oracle application is connected to the database through the SSFS, correct? So in HANA database, we have two mechanisms. Either you can connect to the HANA database through SSFS or through the SDB user store. Okay, so the when we install the application like S4 HANA, B4 HANA, or any ABAP application or any Java application on the HANA database, then there you will get a two options whether you want to install your application as the SSFS or SDB user store. So basically we go with the SDB user store. So that is the easiest method. So in that SDB user store, the database host name, the port number of the database, and the schema user ID and the password is maintained. So whenever your application, whenever you start your application, this application connect to the HANA database using this connection string. So we can see that this is the connection string for your application, between your application and the database. So application uses the SDB user store to connect to the database. Okay. So if your SDB user store is corrupted or deleted, then your application will not able to connect to the database. Then you have to recreate the SDB user store. Okay. Any questions? Other question?
No.
Fine. So how to set up and configure? So the basic configuration is there. So if you the flow is there, if you remember those flow, you can easily do the HSR. It is just a 30 minutes of uh, task for HSR configurations, whether it is HA or the DR. So only the 30 minutes is required to configure once the once your backup is completed. So you have to install your OS, then database, OS, then database, HANA database, the same level. Make sure your primary and the secondary are installed. Uh, Both are same. Okay, so install is HANA database with the same SID, same instance number. Perform initial database backup. So once first two is done, then you perform the initial data backups. Okay, on your primary database. Okay, this is the highly recommended. Okay, without that you cannot set up the HSR. You have to first perform the database backups. Then once database is backup is completed, then you enable the HSR. Who's there? Who back? It's drop out kya? Okay,
No,
fine.
it's fine.
Okay, so once the backup is completed, then you have to enable the HANA system replication at primary database. So some commands are there, simple commands are there. That commands we have to execute from the OS level. Okay. So you can configure the HSR through the OS level or from the HANA Studio as well. So I would recommend always use the OS level commands. Okay. So that is very easiest and the faster one. HANA Studio taking longer times. Okay. So yeah, so I have the screenshot on my website for the HSR configuration through the HANA Studio. You can go through that one as well. But here we will go with the command base. So everywhere we use the command base. So yeah, it's very simple. So once backup is completed, we have to enable the HANA system replication at the primary database. Then the next step is to stop the secondary system. Okay, using the SDB stop command. Then we have to register the secondary system in the HANA system replication. So we have enabled the HANA system replication in primary systems. Now, after stopping the secondary systems, we have to register that secondary system into the primary database. So there is a commands for registration. So we have to execute the commands from the secondary database. So we have to log into the secondary database SID ADM, and then there we have to register. We have to give the some commands to register your secondary database into the HANA system replications. So in during the registration, that time we provide the replication mode, what replication mode we will be using, what operation mode we will be using, what is the host name of the primary, what is the instance number of the primary, okay, what is the site name of my secondary, okay, this information we provide. Once we executed, then we start the secondary systems. Once we start the secondary systems, your replication is start. Okay, so only 4 to 5 steps are there. Perform the initial data backup, enable the HSR at the primary, stop your secondary systems, register your secondary systems into the in the HANA system replication, then start the secondary systems. Okay, once the secondary system is started, your replication will start automatically. Okay. So here are the some commands. Okay. So first take a backups of the primary, then enable the HSR at the primary database. Okay, you have to log into the primary systems. Okay, using the SID ADM, and then execute a command SDB NSUtil. So using the SDB NSUtil, you do the HSR configurations. So here just give SDB NSUtil space hyphen SR underscore enable. SR means system replication enable. Okay, so easily identifiable the meaning of this. Okay, and then space hyphen hyphen the name equal to site. So you give the site name. So whatever the site, the primary database or whatever the primary site, whatever the names you want to give. So that is up to you. Okay, whatever the name you want to give to your primary database. Okay, so I always use the site A, okay, or primary site, or secondary site, something kind of, which identify uh, the location of your database centers, data centers, or you can give the data center name as well. So SDBNS util enable. Once you are executed, then you have to log into the secondary systems. Okay, using the SID idiom, just execute the stop commands. You can use the ACP control or you can use the SDB stop as well. Okay, once it is stopped, then you have to register the secondary systems, okay, into the HSR. So this is the commands you have to execute from the secondary database. SDBNS SDBNS util space hyphen SR registered. Then remote host. Remote host means your primary database host name. Then remote instance is the remote instance means your the primary database instance number. Okay, and the replication mode. What replication mode you want to use? Sync, then sync ma'am, then async, whatever it is, and then operation mode. What operation mode you want to use? Data shipping, log replay, or log replay underscore read. Okay, and then site name of your primary database. Okay, once this is executed, then just start your secondary database using the SDB start or SAP controls. Once you started, the replication is started automatically. So here, once you start, then your full data. So whatever the data you have taken the backups, okay, that backups is transferred to the secondary after starting the secondary database. Once the backup is transferred, then the remaining after that remaining delta or the logs will transfer based on your operation. Okay, these are the basic commands which use for setting up the HA or DR for the HANA systems. Any questions?
So if we try to do it in a HANA Studio, then this registration part will be done in system database.
Yeah, system database. So it is we do only the system database.
Okay.
Okay, so for all the tenant database, for example, so whatever the tenant database we have in the HANA system replication, that will become automatically a part of the HADR. Okay, so this all configuration is basically for your system database, because we are doing the system level configurations, not a individual tenant database. Okay, that's it. So whatever configuration we do, it's for the HANA system replication, that is your system DB, and your tenants automatically part of the your database HSR. So basically, when you set up the replication, okay, so you have to take the backups of your system DB as well as your tenant database as well. So whatever the tenant database you are 1, 2, 3, whatever it is, you have to take the backups of all your tenant database. Okay.
Okay. And sir, for registration, we will have to use SIDADM user.
Yeah. You have to do these all commands through the SID area only. Okay. Any questions? Any other questions? So we'll see this practically. Okay. So maybe that next lectures I'll show you how to do this all through a practical. Okay. No questions? Fine. So if you see that how we can configure the, in one of the project, this kind of setup I have done. Okay, if you see that I have the primary DC, I have the secondary DC. Okay, so in the primary DC, I have the data development quality and the production. So here this is the application. Here we have the database. So if you see that production database, okay. So in the data center, I have the HA standby. Okay, HA standby. So between the production HA and the HA standby, I use the synchronous replication. And from the HA standby to a DR standby, that is the between the, I use the asynchronous. Okay, so this asynchronous mode. So this configuration we do. Okay, is a basis or HANA admin consultant, but a storage level replication. Okay, this is done by the storage team. Okay, so we don't have the visibility here. Okay, fine. So if we don't have any questions, then I can start the new topic.
I have a question regarding the replication.
Yeah.
How do we, so here we see that between the two sites, like standby and the DR standby, HS standby and DR, we choose asynchronous replication. Why to choose that? What is the, like, why
Yeah.
would I not need an acknowledgement from the DR site? It will be good, right, if we have an acknowledgement.
No, yeah, correct. Your point is correct. But the thing is that the connectivity between the primary and the DC. So your secondary uh, data center will be far away from your primary. So SAP recommend that if gap between your primary database and the secondary database is more than 100 kilometers, then you have to use the asynchronous. Okay.
Where,
So
when in this recommendations, is it listed somewhere when we do, like when you set up this entire thing? Is it listed
yeah,
some?
so SAP note is there. If you go and type on a service marketplace HANA system replication, then you will get the frequency asked questions SAP note. So in that it is mentioned. Let me see if I have or not. Just a minute. No, I don't have that that things. Yeah. So SAP notes is there. In that SAP notes, you will get if you type SAP HANA system replication, there you will get lot of SAP notes. Okay, so you look for the FAQ. So in that FAQ, you will get all the details. Okay, so basically, uh, we use for the synchronous if the connection is stable. Okay, if the connection is stable, then we use the synchronous. The connection is always stable within the database, within the data centers. But between two data centers, the nobody will guarantee a good network connections. Okay, so there may be some issues, some network fluctuation. Okay, the bandwidth, the network bandwidth which we use between the primary DC and the secondary DC is low. Okay, the bandwidth is not good, the speed is not good. So secondary database is only we kept for the for any disaster. Okay, secondary side we always keep for the if there is any disaster happen at the primary, then we can bring the secondary data centers. Okay, so we never use the secondary data center regularly. So in the yearly, once we use secondary data center for the DR drills. Okay, so that's the reason the customers and it is not advisable to have the good communication between the DC. Okay, so if you have the high bandwidth, then obviously the cost will be high for the customer. Okay, so yeah, so if the connection is not stable, then in that case we use the asynchronous. Okay,
I have one question.
yeah,
So the last time when we were discussing auto failover, you said that it is only used for fault recovery, and it should be inside the same like within the data centers.
yeah.
So if in this case, like between the production HANA and the HS standby, we can choose for auto failover mechanism also instead of HANA system replication. I mean, setting up
Yeah, so
or
between pacemaker we set only if you have the synchronous asynchronous the pacemaker is not supported for the asynchronous. It is only supported for the synchronous replication. So we can set up the pacemaker between the production and the HS standby within the data centers. Okay, between the two data center the pacemaker will it is not recommended.
No, what about auto failover mechanism? Like, is it recommend can it be done within the same data center instead of the HANA system replication? You said that auto failover is an entirely different steps. Like,
Auto failover means you're talking about the scale out.
yes, yes.
Yeah, scale out is different. So here we are not talking about the scale out. So in the scale outs, yeah, so I'll cover that scale out as well. Yeah, so if you see that scale out is not possible between two data centers. Okay, so because in the scale out scenario your connection should be very stable. Okay, so scale out is only supported within the data centers. In that you will be having the multiple nodes. Okay, multiple nodes means you cannot keep two nodes in the primary data center and then two or three nodes in the secondary data centers. Okay, so that is not supported. So you have to keep all your uh, the scale out nodes in the primary DC one DC only. Okay,
Yeah, understood.
okay, fine. Yeah, this is you're talking about. Yeah. So HANA host auto failover. So in that, if you see that we have the host types like worker then standbys. Okay, so the all the workers host are the active host. Okay, so they are active and they are ready to take a task. but standby is always inactive. So whenever the worker nodes failed, then standby take the control of the failed worker nodes. Okay. So basically for host auto failover to be successful, okay, let me explain my other way. So in the host auto failover mechanisms, we have the name servers. The name servers does the auto failover. Okay, so whenever the any active nodes goes down, then name server will be notified, and then name server will ask standby to become active because one of the nodes is not responding, and then standby is active, and then it takes the control of the fail nodes. So the name server here in host auto failover act as a cluster managers. Okay. Okay, so yeah, so basically, this kind of setup we use for the bigger database, like for the BW systems. If you have BW systems, then host auto failover will be a good, uh, HA high availability for the scale out in the scale out with the standby nodes. Okay, so if you see the diagrams here, okay, so this is just high level diagrams. So we already, many times I have, like, I think last time we also covered this diagram. So if you see here, we have the multiple host. Okay, host one, host two, host three. If you have all the hosts as a active, then it is act as a distributed systems. It will act as a distributed systems that we call a scale out. Okay, okay. But if you add one standby node in the scale out or a distributed systems, then it will become a HA. Okay, so this kind of setup we call SAP HANA host auto failover. Okay, after adding the standby host, at least one we can add. So it is act as a HANA host auto failover, and it is giving you 100% availability. It's give 100% availability. So if any host like host one is down, so if you see that name servers, index servers, name server, index servers, name server, index servers are active in all the active nodes. On standby nodes, if you see only the name server is active, but index server is inactive. So on a standby host, the index server is always inactive. The name server is always active. The name server is always there on each and every nodes, which communicate with each other. Okay, if they did not receive the communication from one of the host 2, host 3, host 1, anyone. Okay, if standby host of name server doesn't get any response from, for example, host 1, the name servers of the standby will you know will consider that that host is not reachable. Then this will communicate with other name server as well. The names other name server will also give the that that server host one is not reachable. Okay, then after that the standby will become active. So name server will bring the standby as a active nodes, and the index servers on the standby nodes will be active. So index servers of the standby at the standby node will only become active after getting the logs and the data of the host one. Okay, so if you see that host one, the data in the logs is pointing to the host one. Okay, if this host one goes down, then this all will point to the your standby nodes. So name server does all these things. Okay, so name servers bring the standby node. Okay, and then all the data and the logs will be mounted to the index servers. Okay, okay, and then this will be offline. Okay, and this will become active. Okay, so this way, if you see, user will not face any downtime. So it's done in the milliseconds. This failover done in milliseconds automatically So if you even we don't have any the control, so we cannot perform the manually we can perform. If you want, then you can stop any the host, okay, and then after stopping that, the resource log and data is automatically the mounted to the standby nodes. Okay, once your failed node is available, okay, then this failed node will become a standby, okay, new standby, okay, and then if any goes this now this host one will be become a standby. If any of the nodes goes down, then this the host will become a active, okay, like this it will work. Okay, any questions here? It is little complicated, complex, but yeah. So as you worked in the if you get the chance to work on this kind of scenario, then you will get clarity how the scale out with the standby nodes it's work. If you do all testings and all that. Any questions? Guys, any questions before I move to the next slide?
No questions.
No questions.
Okay. So this is one of the diagrams which I have done for one of the customers. Okay. So if you see here, I have master. So in the scale out, one will be a master. So whatever the database, the first node we will install as a stand. We will install first on the first node. We will install the HANA database. So that will be a master, and then remaining the nodes we add into the HANA systems. Okay, using the resident as the build channel, like this worker, two workers, and then standby. So you add this into the HANA systems using the resident HDB systems. While adding, you have to provide the types of the nodes. So worker nodes, then worker nodes. Then if you are adding the standby, then you have to provide the types as a standby. Okay. Okay. And then if any node goes down, then this standby will active. All the services will fail over to the standby nodes. Yeah, like this. Okay. So the practical part for the HSR will be the next time. Okay. For now, I'll cover the uh, migration DMO. Okay, we'll go with the DMO. What is the database data migration option? That is the DMO. What is the use of this? So data migration options DMO basically is used to migrate or convert any database to HANA database. Okay, so if you want to perform the conversions or migrations from any database to HANA, then SAP recommend to use the DMO. So what is the DMO? We'll see that. The scenario here, you want to migrate your existing ABAP based SAP systems to a HANA database. You choose the in-place migration, avoiding the landscape change, that is the SID host name. Okay, the classical migration is complex and required several steps to be considered. Okay, so here you have the scenario that you have the systems on the any database like Oracle's or DB2, and you want to migrate to the HANA database. So you have chosen the DMO. So we call a DMO as a in-place migrations. Okay, it doesn't change your SIDs. So your SID and the host name of the primary application server will not change. It will be as is. So that's the reason we call it in place migrations. So here the solution is used to the DMO. So what is the benefit of using the DMO? We'll see that. The benefits: migration steps are simplified. Okay, migration steps are simplified, meaning is that if you use the classical migrations, so classical migration using the SWPM, it is very complex. It is very complex to perform the migration, the export preparations. Then you have to do the table splittings. You identify the tables, top tables. Okay, then you prepare for the table splittings. Then you perform the export using the SWPM. Okay, then at the target you just import it. Okay, so it's little complex process. Okay, so it's required a longer downtime. The export is also required downtime. The import is also required a downtimes. Okay, so in the DMO, the migration steps are simplified. It reduces your downtime. Okay, it reduces your downtimes. Also, you can perform the system update, Unicode conversion, then database migrations in one tool. That is the DMO. Using the DMO, you can perform anything: system upgrade, Unicode conversion, and the database migration. You can combine any of or all in your the migrations. For example, if you have the older systems, okay, it is on non-Unicode systems, and you want to go with the HANA, okay, and also that is EHP 4, for example. Okay, so you want to migrate to the HANA database, then HANA database require a Unicode systems. Then here in this case, you have to perform the Unicode migrations. Okay, then here you also want to perform the support pack upgrade. Okay, like EHP 4 to EHP 8 you want to go, and also you want to change your database. So these things you can do in with the DMO. Okay, this DMO reduce the business downtime. In one downtime, you can do all these things. It reduce your business downtime. Okay, if you consider with the classical migrations, your downtime is increase. If you consider the same scenario, how we'll see that. So if you see that this is the classical migrations. Okay, so if you see here, you have the EHP 6.0, sorry, ERP 6.0, then EHP, you consider it is a 4, EHP 4. Then you have the ABAP servers running on 7.0, then kernel is on 7.0, for example. Then source database, you have like any database, DB, Oracle, consider Oracles. Now I want to go to the target on HANA. Okay, so for HANA, HANA has the prerequisites. Some levels should be there. Okay, EHP 4 is not supported, for example, on the HANA database. For example, I'm just giving the examples. You should have at least EHP 7, for example, if you want to go to the HANA. So here, if you want to go to the HANA, your support pack should be on so and so version. So here you require the upgrade as well. Okay, so EHP 4 is not supported. For example, the supported version we have to use. So here you need to perform the upgrade. Okay, from EHP 4 to EHP 7. EHP 7 required, it is the requirement for the HANA. Okay, because HANA required minimum EHP 7, for example. And also this is the non-Unicode systems. The source is the non-Unicode systems, and HANA supports only Unicode systems. Then Unicode conversion is also required. Then source database is your oracles. You want to convert to the HANA. If you are going with the classical migration, for example, if you are going with the classical migration, then first you have to update EHP 6.0 to EHP 7. One downtime is required. and then perform the Unicode migration. One downtime is required. Okay, second downtime is required. Then migrate your systems from source to a HANA database. Another downtime is required. So here you are migrating from Oracle to HANA database. So here you required one downtime, two downtime, and the three downtime. So this is the classical the approach, which is very longer. You require a multiple downtime if you want to perform everything. With the DMO, it is simplified. Okay, with the DMO, in the DMO, you can combine everything: Unicode conversion, then upgrade, then DB migrations. Okay, in one downtime, you can reach to the target systems. Okay, so this is the advantages of the DMO. Any questions here?
This DM option is embedded in sum itself, like it's a normal how we call the sum and we do the upgrade. That is where this option is there.
Correct. Yeah, yeah. I'll come to that point as well. Yeah. No questions till now. Fine.
No.
Okay. So what is the benefit of DMO? DMO means combined procedure. Only one maintenance downtime is required. It reduce the business downtime. Fewer regression testing is necessary. Only few testing is required. In place migrations keep the application servers and the system's ID stable. So your application the SID will not be changed. Okay. So low impact on the system landscape because of the only the database server is new. Okay. So if you go with the migration, the HANA database migration, then it won't touch your source systems. It won't touch your source systems. Okay. So your application that database source will be as is. Okay. So during the DMO, it transfer the data to the HANA database. So you have to install the HANA database on the new servers. Okay. And then using the DMO, it asks for the database information like the connection details. And then during the downtime, it transfer the application data from your source database target. So it won't touch your source systems. So source system will be untouched. Okay, so here it is mentioned that low impact on the system landscape because only the database server is new. It's upgrade and the migrate the existing systems while keeping the system ID, pass, host name, and connectivity settings stables. Okay, so it won't touch your source systems. Okay, original database is kept and can be reactivated as a fallback. It reduces the risk, no restore is required. So after the migration, if suppose something goes wrong, like application team notice that their business functionality is not working in testing phase, and they decided to roll back everything, then restore will not be required because we have the source database. Okay, we can point the application, our application to the source database, and we can bring up the source systems. Okay, so it won't touch the source database. It will keep untouched your database. So in case of any fallback, you can go easily. Only you require to repoint your applications. Okay, that's it. DMO. Yeah, any questions here till now? Sorry. Fine. So DMO basics, software update manager. What is the software update manager? It is some which is used for upgrading the upgrading the SAP systems. We all know what is the sum. The database migration option, that is the DMO. It is a option in the sum. It is not a tool. Okay, so it is option in a sum. DMO is available with the software update manager 1.0 SP09 and higher. It can be used for system based ABAP. So you can use for the ABAP only. Okay, if you're running SAP on Java, if you're running the Java systems and you want to migrate to the HANA, then DMO you cannot use. The DMO is only for the ABAP systems. You can migrate, your ABAP systems using the DMO. For Java, you have to use the classical method, that is the SWPM, System Export Import methods. Okay. The software provisioning managers, that is the SWPM we call, it is used for installation, system copy, classical migration, homogeneous system copy, heterogeneous systems copy, then the renames, okay, dual stack splits, okay. This purpose we use the software update managers, that is the software provisioning managers, okay. So these three tools we have in the SAP world for the installation and the upgrade or migrations. So DMO basics. So you don't require a certification. So the certification is not required if you are using the DMO. If you are working on of the project where you perform the DMO. Okay, so certification is not required for the OSDB migration. The certificates is recommended. Okay, SAP recommend that the people who perform the OSDB migration, they should have the they should SAP recommend that the consultant should be a certified migration certified. So the migration certified means SWPM, using the SWPM. But if you're using the DMO, the certification, it's not a mandatory. No migration check services is required for the DMO. Okay. So migration check services from SAP is not required if you using the DMO, but in the classical migration, you require the migration check services from the SAP. Okay. So migration key is also required. Okay, during the DMO. DMO is a niche option inside the sums. DMO supports migration to SAP HANA database. HANA to HANA, you cannot use the DMO. It is a homogeneous system copy. You have to use the SWPM. SAP HANA required a single stacks. Okay, SAP HANA required a single stacks. If it is a dual stack, ABAP plus Java, then you have to split. Okay, the ABAP systems only be migrated using the DMO. The Java systems cannot be migrated using DMO. You have to use the SWPM to migrate your Java systems. If you see the phase, okay, so we all know about this phase if you have work on the sum. Okay, so in the sum, if you so for the DMO, we have the separate sums. Okay, so we get two sums. So one is a simple sum, okay, and another you will get the sum for DMO. So that we have to check. Okay, so we have to download the sums for the DMO. So first steps in the DMO phase is the upgrade preparations. In the upgrade preparations, we set up the HANA database at the target new server, and then the upgrade preparations, we specify the client and schema name, the DDIC password. It extract the SID ADM password. It asks you to provide the password for all SID ADM, then schema, then DDIC. Okay, and then you choose the configuration. In the sum, you choose the mode of the configuration mode, like standard or advanced for the sum. Okay, and once that all is done, then in the execution, once it is in the execution phase, it does actually the conversions. Okay, so if you see that once it is enter into the execution phase, then it's migrate the application data. Okay, then the application data is always migrated during the downtime. And then it finalizes the upgrade, and then after that, once all everything steps are done using the sum, okay, then you can start SAP systems on the HANA database. So here if you see that here mentioned that source database continue to run but no longer used to store the data. So your application will be pointed to the your HANA database. Okay. So yeah, the sum will disconnect the application from the source database and it will point to the new database. that is on the HANA after migrations, once your application data and everything is migrated. So the prerequisites, SAP HANA appliance or HANA sys database hardware should be ready. Dual stack, if you have the dual stack, then it should be split. OSDB software may hello, I'm audible.
No, your voice was not audible.
Yeah, now, yeah, I noticed that some issues.
Yeah.
Yeah. So yeah. So OSDB software may need to be updated at source. Okay. So your source, database or OS should be compatible. Okay. So when you run the sum for the demo, it will check the compatibility of your OS and the DB as well. And then in that you will get the you'll come to know that which version, if it is required to upgrade, then you have to update the OS or the database as well. The stack XML is also required. Okay, you have to download the stack XML from the maintenance planner. Okay, so this stack XML is only required if you are doing the support pack upgrade as well along with the uh, HANA migrations. Okay, if you're not doing the support pack, only you are just changing your database, then XML file is not required. For the DMO procedure, you have to select the board. So yeah, so for the DMO, you require the both kernels, source kernels and the target kernels as well. So for example, if you are running the source database like on Windows, okay, Windows application, then you require the kernels. Windows on Oracle, for example, then you require the kernel for Windows and the Oracles for the source, and you are migrating to your application to Windows and then database on the Linux. HANA database will be on Linux. So you require the there also you require the kernels for the your Windows and then HANA database. Yes, two different types of the kernels is required for your source and the target database. Only pure ABAP systems can be migrated on the HANA database. So Java Stack is not supported with the DMO. With the some SP12, the DMO procedure allow you to include the Unicode conversions, so you can perform the Unicode conversions with the some SP10. Depending on the update path, the operating systems and the database software may have to be updated prior to the DMO procedures. Yeah. So update part means operating systems and the database software may have to be updated. So when you run the DMO, if you do the POC, in that you will come to know that we come to know that whether the operating systems or database software at source required to be updated or not. Web browser update may have to apply. Yeah, so because the DMO or some runs on the browsers, so we get the URLs, and that URLs we use, and then with that URL we do all the installations. So nowadays the installation is based on the URLs. So earlier we used the graphical user interface. Now that is not required. So requisite, you have to download all the DVDs from the download managers. Okay. Through the maintenance planners, the spams and everything. The sum it will automatically download host agent, HANA clients. Okay, everything it will download the maintenance planners. If you're not going with the maintenance planner for the if you're not going with the upgrade, for example, you just only going to change your HANA database, then you have to download the host agent HANA clients, okay, HANA database, you require the migration key as well, you require the license as well. Okay. Okay, so spam or sand and the XML files only is required if you are going with the upgrade as well. If you are including upgrade in the HANA migration, otherwise it is not required. Then move all the XML stacks file down, whatever you have downloaded into the on a servers. Okay, on your source servers, you have to copy everything in one folders. Okay, and then you can start the sums. Just some will be SAR files. So you have to extract the sums under user SAP SIDs at source location, and then you start the sums. Once you start the sums, you will get the URLs. That URLs you have to use in the browsers, and then provide the user ID, the password, and then after that you can proceed with the sum. So some of the screenshot I'll show you that for the DMO purpose. Okay, so what are the main screenshot for the DMO? We'll go through that one. So once you start the sums, okay, password. Yeah, again some issue I think for the team. Okay, so once you put the URLs, okay, so what happened in the backgrounds? So URL will ask you user ID and the password. Once you give the user ID and the password, it will get connected to the SAP host agent, and then SAP host agent will start the SAP up. SAP up is nothing but SAP upgrade, and then SAP upgrade will start call the TP and the R3 trans and the R3 load based on the during the downtimes or during the up times. Okay, whenever the TP and the R3 trans and R3 load is required, the SAP up will call. Okay, so if you see here the screenshot here, so here you have to provide the SID ADM. So once you run the sum, okay, then you will get these URLs. You use that URLs, and then here you have to put the SID ADM and the password. Then after login, you will get this screen. So here you have to specify the stack XML. Okay, so provide the stack XMLs. Then it will ask you, DDIC user ID and the SID ADM password of your source. You have to provide that one. Then here is the options for the PMO. If you see that. Okay, so here if you see that SAP HANA, migrate to SAP HANA or SAP ASS. If you select no migration, that it won't perform the migration. It will do the only support pack upgrade. If you want to perform the support pack upgrade and the HANA migration, then use the SAP HANA migration. And if you want to only the migrate to HANA, then just choose the SAP HANA and then click next. Okay, so this is the database migration. If you see here it is mentioned. So only it gives the options. Okay, you just select and click next. And then after that, it will ask you the migration key. You have to provide the migration key. And then after that, it will show you this is the source system. So if you see that details of the source systems. So if your operating system is not compatible, then it will ask you to install your you have to upgrade your operating systems or the database. So it is checking your database informations, the source database and the source OS. Okay, if it is compatible, then it will go give as a information. If it is not compatible, if it is asked to upgrade, then you have to plan for the upgrade as well. Yeah. And here you have to choose the configuration, standard configuration and advanced. So based on your requirement, so standard in that one, the downtime will increase. Okay, in the advanced, downtime will be minimized. So if you have work on this sum, then you will know about this all is what is the standard and the advanced. Okay, so to use the DMO, you should be, good on the sum tools. Okay, so you should at least know about how the sums are, working. Yeah. Okay, so yeah, so always use the advanced, not always. So depends upon your requirement. You can go with the standard or advanced as well. Okay. Then here you require the HANA clients because your application will be connected to the HANA database through the clients SDB user store. It will use to use the SDB user store. The application that need a HANA clients to communicate with the database. And here you have to provide the password for SID of source. Then next screen here you have to provide the database in details. Host name of your database, then SIDs of your database, instance number of your database, and then license of your database. This is all you have to provide. Okay. Then the system user ID and the password. Okay. You have to provide. Then DB cockpit password you have to provide for your database. The DB cockpit will be created. Okay. So your application DB cockpit transaction is there. So it will get configured with this DB cockpit users. The schema user ID and the password. You have to specify the schema user and password for your database, HANA database. So these all details are the database. And then after that, this much information is only required for the DMO. All steps are is for the sum. So I have the screenshot of the one of the POC. Okay. So if you see here, I'll share this one as well. So, so this is the HANA migration using this sum. Okay. So also the support pack upgrade was there. Okay. So update the existing kernels to a latest. On the source, always use the latest kernels. Update SAP host agent always. Download and generate the XML files. Download the latest sums from the below links. So if you see that you will get a two the sums. Okay. So here is the if you see that sum above software update using the sum and the DMO for using the sum. So two sums are there. For the HANA migration, we always use the database migration DMO using the sum. Okay, that we use. So download, then here is the sum directories, download directories. Okay, then here is the sum. You have to extract the sums under the USR SAP car -XVF. Okay, once it is done, then you have to run the startup.batch. This is on the Windows. Okay, so startup.batch config host. Okay, okay, then it will show you like this. Then here you have to use the URLs. So if you see that these all are the URLs. Where, yeah, down. Here are the URLs. Some ABAP. So you use this one. This URL you have to copy and then open in the browsers. You have to open this one, this URL. Okay. Then copy in the browsers. You will get these screens. You have to provide the XML files. Then after providing the XML files, okay, then it will show you this informations. Okay, after clicking next, it will extract all the SAR files. It will check. Okay, and here it is asking for the user ID. Did I see user ID and password? Okay, then yeah, then here is the checking the source kernels. Okay, SAP kernel and all that. It's checking the source. Yeah. Then whatever the downloads, whatever the files we have in the downloads, if you expand, you'll get the informations. Then here you'll get the options for the HANA database migration DMO, then migration key, Then this is the SPDD and SPOW. Okay. Okay, so SPDD, if it is any SPDD, then you have to perform your two SPDDs there. Yeah, so this has to be performed immediately. This is the information only of the next phase. Yeah. So it is switching to the next phase from extraction to the configuration. Okay, is enter into configuration. Now you are in the configuration. You have to select your configuration standard or advanced. Then here you have to specify number of, the processes, uptime process, downtime process, and all that. Okay. So this is part of the sum. So if you have worked on the sums, then yeah, you know already this one. So I'll share this all these things here. The only thing is that when you use the DMO, it asks for the information about your database. Yeah. So that is very, very important that we have to give. So here I have downloaded the HANA clients. Yeah. They provided the HANA clients. Okay. The SID ADM password. Okay. Then database information. Then these are missing SAP nodes. Okay. So we have to apply this all missing SAP nodes and then continue once apply. Then target database system password. Then target database system DB ka password, system users, and yeah, then schema password. It is also schema password. Yeah. So use existing tenants. If you have the tenants already created, then you select use existing tenants. Okay, then this is all the add-ons which is there on your source. So based on your the XML, it will show you these screens. Okay. These all are the support pack which will upgrade with the DMO. Okay, so here it will open create a shadow instance because here we use the advanced configurations. So in that advanced, it will create a shadow instance, shadow systems. Okay. And then in pre-processing phase, it will lock all the developments. So the development will not be done. Okay. So it lock all the developments. Then it will take some times here. Okay. Face to face during, so refer this SCP note. Yeah. And pre-processing, then yeah. So here it takes some time because it creates a shadow systems. Okay. And yeah, then after that you will get these screens. It asks you to perform the backups and stop the database and they perform the backups. Stop the application and then perform the database backup. Once the backup is completed, just confirm, and then once you confirm, it will enter into the execution phase. Backup completed, then it will enter into the execution phase. Once it is entered into the execution phase, then the downtime will start here. Okay. And then in this phase, the conversion, support pack upgrade, and switching to the new kernels, new database will happen. Okay. Yeah, so this is after the upgrade. We'll get this one. So in between, I logged in and I checked the database, the process, memory loads, and all that. Okay, in executions, the main thing is happening in the executions. So you will face a lot of issues once, but whatever the issues always come new. So it is not like that. Whatever the issue I face, the same issue you will get it. So all it depends upon your source systems. Okay, so yeah, execution is completed, then it will enter the post processing. Okay, and then you continue with the SPOW if there is any SPOW. Okay, no SPOW. For the SPOW and SPD, you have to involve your BAPR. Okay, then yeah, you'll get this screen. Then your upgrade is completed. conversion upgrade is completed. Then you can run the SGen, okay, perform the SGen and all that. Okay, so I'll share these screens, these documents as with you. Then you can go through that, yeah, for your understanding purpose. Okay, any questions here?
I have two questions.
Yeah.
First is this option of migration. It also comes, you said that we have to use the sum for the DMO tool, but it
Yeah.
is also available in the normal sum, right? The one
No.
that you.
No, normal sum you won't see.
Okay.
If you see, yeah, I'll show you that. If you go on the on this link, okay, it will show you this one, software update. Okay, if you see the software update or upgrade, software update or upgrade using this sum.
Okay.
Okay, so in that sum you won't get the DMO options. Here you will get the upgrade. So if you are running the any application on the any database and you want to perform the support pack upgrade, then you will be using this one. Okay, and if you want to perform the DMO, conversion, database migration, then there is another sum which you have to use in that one, either 1.0 or 2.0.
Is it to do something with the SP level? Because I used SP25 recently and I can see this option is there. So is it probably I downloaded the
This
DM?
one,
Okay, okay.
yeah, you have downloaded the what was the version? Sum 1.0, 2.0.
1.0 SP25.
Yeah, so
Perfect.
1.0 is supported for 7.50 only. If you have the 7.50 and above, you have to use the sum 2.0.
Okay.
Okay, below 7.50 ACP basis 7.50, you have to use the sum 1.0. Okay, like ECC systems. Okay, but if it is higher than 7.51, 7.50, like 7.51, then you have to use the sum 2.0. Okay.
The second question is, if my EHP level is not, I mean, I want to migrate to HANA, but my EHP level is not as it should be, I mean, EHP 7 before migrating. So when I start the sum, the first task will be to the normal upgrades that we do, like coming to EHP 7 level.
Mm-hmm.
And then it would be followed by the DMO migration option, or is it like both of them will be happening together? Because if we are minimizing the downtime, then both the options should be selected together and then we proceed.
Correct. So both options will go. If you go with the upgrade and the HANA database migration, then both will be done in the downtime phase.
So during the configuration phase, I will proceed with like the upgrade to HP 7 related files, as well as the options for the migrations, whatever will be required. We put in all the configurations over there, and in one shot it will be done.
Yes, yes. Based on the XML, what are the XML you have selected, the support pack, target support pack, it will go directly. So it will use the XML.
Okay. Okay.
And then there in the demo, you'll select that HANA, SAP HANA. So it will do both, support pack upgrade using the XML files, and then you have selected the HANA, and it will move to the HANA.
But we are also providing, I mean, if I see your screenshot, we are providing another stack XML file, right? What is that XML file for them?
No, yeah, I need to delete that one. Yeah,
So we
only one
don't.
X. Yeah, so we don't need to. Yeah, yeah, so actually I provided the wrong one. If you see that, yeah, something kind of. So yeah, so if you see the duplicate, then remove that one. Yeah, only one. Yeah, one is there only. Yeah, only one is there. This
Yeah, but this stack XML file is for
support pack
migration.
upgrade.
Support pack upgrade. Okay.
Yeah, so the for the only the Oracle to HANA database migration, no stack file is required.
Yeah, okay.
Okay, so stack file is only required for if you are including your upgrade with the HANA migrations. That's all. Any other questions?
No question from my end.
Fine. If no question, then we'll stop here and then tomorrow we'll continue then.
So server is up, like,
Server I have stopped, so if you need, I'll start it.
okay. We can start it.
So ping me if you require, then I'll start it.
Okay. I'll be.
Okay. Fine. So no questions, then we'll leave for this.
Sir,
Yeah,
will you
thanks.
upload this document? Like,
Yeah,
the-
I'll upload. Yeah.
Okay, thank you.
Okay. Yeah, thank you so much. Thanks. Bye,
Thank you.
everyone.